Alrighty, here is your key to your test review. So we're going to start with evaluating this piecewise function. So I'm looking for h of -7, so I have to look and see which of these two this would fit into. So -7 is less than -3, so I'm going to substitute it into this first one. So h of -7 equals the absolute value of -4 times -7 plus 7. So that gives me the absolute value of a positive 28 plus 7, which is positive 35. So h of -7 is 35. All right, h of -3. Well, -3 shows up in both of these, but it's only included in this one. So I substituted in the last one. So -3 cubed plus 2 times x, oops, sorry, gotta substitute that in there. X is -3 squared. So this is going to give me negative, and then -3 cubed is a -27. -3 squared is a positive 9. So -27 is positive 27 plus 18. So 27 plus 18, if I add 20, I get 47. Subtract 2, and I get 45. So h of -3 equals 45. There you go. All right, parent functions. So we need to sketch each one of our parent functions. Linear, which would be the line. This would be the line y equals x, or f of x equals x. And absolute value looks like this, and f of x equals the absolute value of x. Quadratic, oh, that's fine, it's kind of fat, but it's all good. F of x equals x squared. Cubic, got that point of inflection there. So f of x is equal to x cubed. Square root, looks like this. So f of x is equal to the square root of x. Cube root, we have another point of inflection, but it's laying down this time. So f of x is equal to the cube root of x. Reciprocal, so I have asymptotes here on the axes. And then looks like this. And that is f of x equals 1 over x. Notice that the variable's in the denominator. Some of y'all are wanting to make reciprocal functions out of things that just have fractions in them. The variable has to be in the denominator. Signum looks like this. And we could say f of x equals the absolute value of x over x, or you could write it as the signum of x equals the absolute value of x over x. You could also write this as a piecewise function and say it's equal to -1 when x is less than 0. It's equal to 0 when x equals 0. And it's equal to 1 when x is greater than 0. Any one of those is fine. All right, 15. If the quadratic parent function, which would be this, f of x equals x squared. The quadratic parent function is reflected in the y-axis and vertically compressed by a factor of 1/2. Write an equation to represent the new function. Okay, so that means that my new function, g of x, so we're going to reflect it in the y-axis. If I'm reflecting it in the y-axis, it's on the inside of the squared. So it would be like this, -x squared. Vertically compressed, that's on the outside, and y doesn't lie, so it's multiplied by 1/2. And that's all. we vertically compress it and reflect it. All right, so then we want the cube root. It says if the cube root parent function, so that means this is f of x equals the cube root of x. Cube root parent function is horizontally, remember I told you to change this to, it should say compressed. That's what that word right there should be. Horizontally compressed by a factor of 1/4, then translated 5 units right and 3 units up, write an equation to represent the new function. All right, so g of x could equal, so we're horizontally compressing it, which means it's inside with the x. So we multiplied by a factor of 4, since it's compressed by a factor of 1/4, we're going to multiply by 4. But it's also translated for 5 units right. So I'm going to have to do x minus 5. That's how I translate it 5 units right. Parentheses around that. Multiply it by 4. Okay, all this stuff has to be inside the cube root. Okay, so I have horizontally compressed it by a factor of 4, translated it 5 units right, and on the outside, 3 units up. All right, so then the absolute value parent function. Okay, absolute value parent function, f of x, is equal to the absolute value of x. Has transformations applied such that it creates an absolute maximum at -2,7. So if I was to plot that point, -2,7 would be like right there, if I'm just going to ballpark it. Since this is the maximum, I know it has to open down like that, which means a reflection in the x-axis has happened. Okay, so I know I have to reflect in the x-axis, and I'm going to have to translate it left and up. Now, it could possibly also be stretched or compressed, we don't know, but this wording, write an equation that could represent. So you're not saying for sure this is it, because we don't know what else is going on except for the absolute maximum. So we don't even have to worry about stretches or compressions. So I'd have g of x is equal to, if I'm going to reflect in the x-axis, then the negative is on the outside, absolute value, and I've got to move it to the left. So if I translate to the left 2, that means I'd have x plus 2, and then up 7, we plus 7 on the outside. All right, so then a certain function, we don't know what it is, well, it's absolute value once you see this, is vertically stretched by a factor of 2. That means that's going to affect this number right here. Horizontally compressed by 1/4, that's going to affect this number right here. Translated down 6, that affects this number. So all 3 numbers that are already there get affected, and it says this is the new function. I am looking for the original function, which means I got to work backwards, right? So g of x. Okay, if it got stretched by a factor of 2 to get here, that means some number had to be multiplied by 2 to get 6, so that would be 3. If it was horizontally compressed by 1/4, that means it got multiplied by 4. Well, you would have to multiply 2 by 4 to get 8. And then it was translated down 6, so to go down 6 to get to -2, you'd have to be at +4. I think that going the other direction is a lot easier for you, and so when you do these and you have to work backwards, then you can check yourself, right? And you can go back and pretend like it's one that goes the other way. I'm going to vertically stretch it by a factor of 2. That means this number would get multiplied by 2 to give me a 6. That's good. Then I'd be horizontally compressed by 1/4, which means this would be multiplied by 4, which would give me 8, so I'm good. And then translated down 6, so I'm at +4. I go down 6, that would get to me to -2, and I'm good. And that's one way to go through and check yourself on that. Okay, so I'm going to describe all the transformations here, the parent function. Remember, when you describe them, you're most likely describing them in the order that you would do them, so you want to make sure you leave your translations till last. Okay, so I'm just going to go in order that I see it. This negative sign is on the outside of the cubed, so that means that I'm going to reflect in the x-axis. Then this 3 is on the outside, so I have a vertical stretch of a factor of 3. And this 1/2 is on the inside with the x. It's on the inside of the cubed part. So that's going to affect it horizontally, and x lies. So this is actually a horizontal stretch with a factor of 2. And then this 7 means I'm going to translate up 7. All right, so now I'm going to describe all of these transformations. So again, I'm going to start from the left. This is on the outside of the square root, so that means it's affecting me vertically. This is less than 1, not just because it's a fraction, but because it's less than 1. It is a vertical compression by a factor of 2/3. Then I move into here. This negative is on the inside. It directly affects x, so that means that we are going to reflect in the y-axis. Then these are both translations, so then I'm going to translate right 5 and up 2. All right, on 21. We're going to graph each function and identify all key characteristics. All right, so this is not set up exactly like that homework was, but on the test, you will have to name the parent function and sketch it. So this parent function, this is a reciprocal, which means that gives me g of x is equal to 1 over x, and it looks like this, right? And I have asymptotes in there. Okay, so my transformations then are this 3, okay, if it's in the numerator, and remember, whatever you decide, if it's a vertical or horizontal compression or stretch, it could be vertical or horizontal, whatever that is. I think that it would be easiest for y'all, if there is a number in the numerator, use that as your vertical stretch. So this is going to be a vertical stretch and the factor is 3. And then I'm going to translate. This gives me to the right 4 and down 1. All right. So when I go over to graph this, okay, I've got a couple of things. With the reciprocal, I have asymptotes, and I have to fix my asymptotes first. Remember, they start off on the axes. Start off right there. But the translations are what are going to take care of moving my asymptotes. So if there's a translation of right 4, this asymptote that was on the y-axis moves to the right 4, and it's here. And then the one that was on the y-axis translates down 1, and it ends up here. Now, your anchor points, whether or not you actually put your anchor points on your graph to begin with is totally up to you. You do not have to. I'm going to on here, though, just so I don't lose anybody. But if you don't put them, you at least need to know that's where you need to put your pencil. With the reciprocal, remember, you only have 2, right? So my anchor points are here and here. So that's where I'm going to start. And so I'm going to start with this anchor point. I'm going to vertically stretch it by a factor of 3. Vertical stretch means that my y value gets multiplied by 3. My y value is 1. My y value becomes 3. Then I translate to the right 4. 1, 2, 3, 4. And down 1. There's a point. Then for reciprocals and reciprocals only, you go back to your anchor point. And now we're going to do this again, but we're going to use a horizontal stretch. So my x value is 1. My x value becomes 3 because it's a factor of 3. Then I translate to the right 4. 1, 2, 3, 4, and down 1. And so then I can go back, then I go to this anchor point. It's the y is negative 1. Vertical stretch would make it negative 3. Translate to the right 4 and down 1. I go back to that anchor point. Now I'm going to do a horizontal stretch. X is -1, so X becomes -3. I translate to the right 4, 1, 2, 3, 4, and down 1. Okay, so I've got 2 anchor points in each section, and it's going to hug the asymptote, and that's what's going to, I can't see where I'm drawing. Okay, something like that. Mine would be much better if it was on paper. It still wouldn't be perfect, but it would maybe look a little bit better than that. Okay, so there we go. There's my graph. So now we look at domain, range, and all that stuff. My domain, the x's go from -infinity to 4. And then I pick back up and go from 4 to infinity. Domain and range and stuff, you still need to be doing those in interval notation. Range, I go from -infinity, and it stops here at -1. And then I pick back up at -1 and go to infinity. My x-intercept. Okay, so here's the x-axis. I already have that point. This is not a guess. I know what my x-intercept is. My x-intercept is at 1, 2, 3, 4, 5, 6, 7, 0. And I only have one of them. My y-intercept is somewhere right here, but I can't guess at what that is, so I have to find it. Your y-intercept is the ordered pair when x is 0. So what I'm looking for is f of 0. F of 0 is equal to 3 over 0 minus 4, minus 1, which gives me -3/4 minus 1. So f of 0 is -1 3/4. Now, some of you may be thinking, oh my gosh, I can't believe she's going to let us leave it as a mixed number. But if it's naturally a mixed number, we can leave it and it's fine. What I don't want you doing is taking something that's not a mixed number and making it into 1. If you made this into an improper fraction, 1 times 4 is 4 times 3, it would be -7/4. So really either one of them is fine, but I am not taking a decimal. So this is 0, -1 3/4. Okay, critical points include my maxes, my mins, and my points of inflection. I have none. Increasing, well, it's decreasing here, decreasing, it's decreasing the whole time, so it's none. And then it's decreasing from -infinity to 4, and then union 4 to infinity. In behavior, as x approaches infinity, f of x approaches, all right, so as x approaches infinity, f of x approaches -1. And as x approaches -infinity, f of x approaches -1. Okay, and there is your reciprocal. Alrighty, so our next one. All right, I got interrupted, so I don't know what the last thing I said was, but number 22. This parent function is a quadratic, and that means that g of x is equal to x squared, and it looks like this. So our transformations here, this 2 is on the outside, so this is going to be a vertical stretch factor of 2, and then these are translations, so I'm going to translate right 3 and down 4. Oh, down, that says down, down 4. All right. My anchor points, which you don't have to put on here, again, as long as you know where to go to start, you don't have to put them on here, but I'm going to put them on here. And I decided I didn't like the stars so much. The X's work a little bit better. And if you don't remember exactly what they are, 0, 0, obviously. You substitute in 1, you get 1. You substitute in 2, you get 4. So these are my anchor points for my parent function. Then those are going to be my starting places to do my transformations. So I started 0, 0. I vertically stretch it by a factor of 2. I'm still at 0, 0. Then I translate right 3, 1, 2, 3, and down 4, 1, 2, 3, 4. So then 1, 1. I'm going to do a vertical stretch of factor of 2. That means the y gets multiplied by 2. So I'm here. Now my y value is 2. I translate to the right 3 and down 4. Okay. I have symmetry, right? So I can, that's my other point there. That would be the negative 1, 1. So then I can go to 2, 4. And I have a vertical stretch of a factor of 2. My y value is 4, so my y value becomes 8. I translate to the right 3 and down 4. There's my other point, and then I have symmetry, so there's the other one. So my pink ones are my transformed points. My parabola would look something, oof, almost, just a little bit. Okay, let me come back. Let me come down from this way. Maybe I can get that a little bit better. It shouldn't curve out like that, but I give up with this pen. So it looks something like that. All right, so my domain, negative infinity to infinity. My range, 1, 2, 3, 4. That's going to be negative 4 to infinity. And I do include my negative 4. My X-intercept, okay, so I don't know what they are, but they're right here. And I have 2 of them, and I do not get to guess off of my graph. My X-intercepts are the points where y is 0. So that means my y, which is my f of x, has to be 0. And that is equal to 2 times x minus 3 squared minus 4. I solve for x. So I'm going to add 4 to both sides to get 4 equals 2 times x minus 3 squared. I divide by 2 and I get 2 equals x minus 3 squared. So to get rid of the squared, I'm going to have to take the square root of both sides. When I introduce a square root, this becomes plus or minus the square root of 2. That's where you get your 2 answers from. That's equal to x minus 3. So then I add 3 to both sides, and I'm going to get x equals plus or minus the square root of 2 plus 3. Or you can do 3 plus or minus the square root of 2. It really doesn't matter either way, but those are my x values, and so that is plus or minus the square root of 2 plus 3, comma 0. So that counts as 2 points because you got your plus or minus in there. All right, so my y-intercept. Your y-intercept is the y, this is the ordered pair where you have a y value when x is 0. So that's where you find f of 0. So f of 0 is equal to 2 times 0 minus 3 squared minus 4. This gives me 2 times negative 3 squared minus 4, which is going to give me negative 3 squared is 9 times 2, so 2 times 9, 9 minus 4. It's going to give me 18 minus 4, which is 14. That is my y value, so my y-intercept is 0, 14. Critical points. This is one right here. That is an absolute minimum, and that is at 1, 2, 3, 1, 2, 3, 4. So this is at 3, negative 4. And that is an absolute minimum. Okay. It's increasing from here to infinity, and so that is at 1, 2, 3. So it is increasing from 3 to infinity, and it is decreasing from negative infinity to 3. In behavior, as x approaches infinity, f of x approaches, well, as the x values get bigger, the y values approach infinity. As x approaches negative infinity, f of x approaches, so as my x values get smaller, my y values approach infinity. And there's 22. All right, 23. We're graphing this one. This is a cube root. Right. And that means g of x is equal to the cube root of x. And it looks like that. My transformations, this 2 is on the outside. That is going to be a vertical stretch, a factor of 2. And then these are both translations, so we're going to translate left 4 and up 3. So my anchor points, which you don't have to put on the graph, but we can, they are these 3. And then you got these out here, so we got to go to 2, 4, 6, 8, 2, because the cube root of 8 is 2, and then -8, -2. So there are my anchor points. So I'm going to start with 0, 0. I'm going to have a vertical stretch of a factor of 2, so I multiply by 2. I'm still at 0, 0. Then I translate left 4, 1, 2, 3, 4, and up 1, 2, 3. Then I go to 1, 1. Vertical stretch by a factor of 2, so my y value is now 2. I translate to the left 4 and up 3. All right, so I just had to pause again because I got interrupted again. I have no idea what the last thing is that I said. So I got these 2 points plotted here. So now I'm going to go to this anchor point. And I'm going to do a vertical stretch by a factor of 2. My y value is -1, so now it becomes -2. Then I'm going to translate to the left 4. 1, 2, 3, 4, and up 3. And here's my other one. So this is my point of inflection. I've got these 2, but I've got other points to put on here. Now if I use this anchor point, when I stretch it and then translate it left and up 3, it's way off the graph. But this one will be okay. So here, I'm here at 8, 2. I'm going to do a vertical stretch by a factor of 2. So my y value is 2. My y value becomes 4. I translate to the left 4, 1, 2, 3, 4, and up 1, 2, 3. So then my graph comes in and looks like this, something like that, but always better than whatever I have. And don't forget your arrows. So now I'm going to look at my domain and range. So my domain is -infinity to infinity, my range -infinity to infinity. My x-intercepts, well, I have one somewhere, maybe right around here, or maybe my curve isn't perfect on there, but I can't guess either way. So I need to find my x-intercept. Your x-intercept is your x values, or your ordered pairs that has an x value when y is 0. So I have to substitute 0 in for y. So 0 equals 2 times the cube root of x plus 4 plus 3. So I'm going to subtract 3 from both sides. So I get -3 is equal to 2 times the cube root of x plus 4. So then I have to divide by 2 before I can do anything else. So I'm going to get -3 halves is equal to the cube root of x plus 4. Okay, so to get rid of the cube root, I'm going to have to cube both sides. Cube this. So when I cube this, it's negative. It's going to stay negative because it's an odd exponent. 3 cubed, so it's going to be -27/8 is equal to, and then I'm just left with x plus 4 here. So then I subtract 4 from both sides. That'll give me -27/8 minus 4 equals x. So I have to combine these, so I need a common denominator. I'm going to put that over 1. My common denominator is going to be 8. So if I multiply this by 8/8, that is going to give me -27/8 minus 32/8. And then that's going to equal, so those are both negative, so I combine them. That's going to give me -59/8. That is my x value. Okay, so that does not divide evenly. I'm not changing it into an improper fraction. If I needed to actually find the value on the graph, then yes, I would, but I'm just going to leave it. So I get -59/8, comma 0. Then I need to find my y-intercept. My y-intercept is about right here, but I don't know exactly what it is, and I do not get to guess off the graph. Your y-intercept you get when x is 0, so I need f of 0. It's going to be 2 times the cube root of 0 plus 4 plus 3. Okay, so that gives me 2 times the cube root of 4 plus 3. So, can I take the cube root of 4? No, I cannot. So I cannot simplify this anymore. This is my y value, so my ordered pair is 0, and then 2 cube root of 4 plus 3. Don't be afraid of weird-looking answers. Okay, critical points. This is one right here. That is my point of inflection, so that is at 1, 2, 3, 4. It's at negative 4, 3. And that is the point of inflection. Oh, goodness. All right, increasing. Well, it's increasing over the entire domain, so it's negative infinity to infinity, which means it doesn't decrease at all. As x approaches infinity, f of x approaches infinity. And as x approaches negative infinity, f of x approaches negative infinity. And there is 23. All right, 26. I know the numbering makes no sense. Just get over it, it's fine. We're going to graph this function and identify the domain and range. So we got a piecewise going on here. So I have 3 pieces. This is linear, this is absolute value, this is square root. So from negative infinity to negative 4, I'm going to have the linear. So I got to figure out where the endpoint of this section of my graph is. So I need to substitute in this negative 4 into right there. So it'll give me negative 3 halves times negative 4 minus 6. So that gives me negative or positive 12 divided by 2, which is 6, minus 6, which is 0. Okay. And so my ordered pair then, okay, that number I got was my y value. The ordered pair that I plot is negative 4, 0. And because this is not equals to here, it's open. So I go to negative 4, 1, 2, 3, 4, 0, and I have an open circle. So from here to the left, I'm going to have this graph, right? And it's the graph of a line. I know what my slope is. It's negative 3 halves. Okay? Make sure you can, if you need to think about this, plus, minus, 0, undefined. Right? So negative slope means my line's going to slope this way, but that I cannot draw it over here because that makes no sense. I don't get to go any farther in the x's, so it's going to be like this. My slope is 3 halves, so I can go up 3, 1, 2, 3, over 2. There's my other point, and then I draw in my line. It looks something like this. And on this side of it here, I have an arrow. Okay, so that's section number 1. Then I go to section number 2. It has 2 endpoints, both of which will be closed circles, right? And so I substitute negative 4 in here, and the absolute value of negative 4 is 4, but then I make it negative, so it'll be negative 4. So this is negative 4 will be an endpoint. So negative 4, negative 4. Then I substitute 1 in. The absolute value of 1 is 1. Make it negative, you get negative 1. So I got 1, negative 1. That's my other one. And that's an endpoint. Okay, so now I have to graph what's in between there. And it is an absolute value function. So I use my anchor points. Okay, I'm not going to draw them on there this time. One anchor point that I have is 0, 0. The only transformation here is that I reflect it in the x-axis. So that means that is still my vertex. When I go to 1, 1, the only thing I do is reflect it in the x-axis, so that's that other point there. I go to negative 1, 1, reflect it in the x-axis. Negative 2, 2, reflect in the x-axis. So I got everything that I need, and I can connect these with the straight edge to get that part of my absolute value. Then I do the third piece. So I substitute in the 1 here. So 1 minus 1 is 0. Square root of 0 is 0. Then 3. So the ordered pair is 1, 3. But that will be an open circle because it's not equal to. So I go to 1, 1, 2, 3. Open circle here. And it's going to be square root. Right. Do my transformations. So my anchor points, I get 0, 0. Right, is my first anchor point for my square root. And what I'm going to do from those transformations. I'm going to move to the right 1 and up 1, 2, 3. So that is that point that I would transform. So then I go to 1, 1, and I would move to the right 1 and up 3. Then I go to 4, 2. That's my third anchor point. Move to the right 1 and up 1, 2, 3. Those are the 3 points I need to get my curve like this for my square root. So there's my piecewise with my 3 pieces. So let's talk domain and range. Go from negative infinity for my x's. All these x's work. Oh, there's nothing there, but it gets taken care of there, so I'm good. Keep going on my x-axis. Oh, that's good, so I keep going. So my domain is negative infinity to infinity. My range, I don't start down here at negative infinity. I don't have any y values I'm using until I get to here. So that's it, 1, 2, 3, 4. So I start at negative 4. I go up, all these y values are accounted for, including that one, then I keep going and all the way to infinity. And I do include negative 4. Discontinuities, I have 2, and they are both jump. So I have jump discontinuity at 1, 2, 3, 4. X equals negative 4 and x equals 1. Remember, just because these are open circles, that is not removable. Removable if there would be if there's just a random point missing. And then if you have an asymptote, that is when you have infinite. Okay, function operations. So we have to state our domain, and we have to add, subtract, multiply, divide, whatever they're asking us to do here. So I need to look at each of these domains to begin with. The domain of this, it's a line, it's all real numbers. This domain is not all real numbers because what's underneath here has to be greater than or equal to 0, which means x has to be greater than or equal to negative 7. And then here, this again is all real numbers. So remember, when you're adding, subtracting, multiplying, or dividing, your domain is the intersection of the domains of the two functions that you're combining. So we have to keep that in mind. So when I go to do g plus f of x is all real numbers, g of x is not. So the intersection of these two would be this. This is going to have to be my domain when I finish. So g of x, which is the square root of x plus 7, plus f of x, which is 3 minus 2x, and there is nothing I can do to simplify that. That equals g plus f of x, and my domain, the intersection of these two, is that x is greater than or equal to negative 7. This whole thing is my answer to 34. 35. I'm going to do h times f of x. So h is x squared minus 5x times f of x, which is 3 minus 2x. Okay, and so those parentheses there are important. I need to FOIL. So that's going to give me x squared plus, or times 3 is 3x squared. The outside 2 would give me negative 2x cubed. The inside 2 would give me negative 15x. And then the last 2 will give me positive 10x squared. So then I need to combine my like terms and rearrange this in order. So h times f of x is equal to negative 2x cubed plus 13x squared minus 15x. Okay. And then my domain. Okay. The domain for h is all real numbers. The domain for f is all real numbers. So this domain is all real numbers. All right. So here's the quotient. Okay, for the quotient, h, or whatever's in the denominator, cannot equal 0. So here I've got x squared minus 5x cannot equal 0. So x squared minus 5x cannot equal 0. So I got to figure out what the x's have to be. I can factor out an x. That leaves me with x minus 5, which cannot equal 0. So that means x cannot equal 0, which is important. And x minus 5 cannot equal 0, which means x cannot equal 5. right? So those are two domain restrictions that I have in addition to anything else. Well, H was all real numbers, F was all real numbers, so there weren't any restrictions beforehand. But then I have to figure out what this is. So F is 3 minus 2x over H, which is x squared minus 5x. There's nothing I can do to simplify that. I mean, I can factor an x out of the denominator, but it won't cancel anything with the numerator. So this is F over H of x. And my domain is all of the x's such that x does not equal 0 or 5. Okay, and this is my answer here. Okay, so now let's evaluate these. So g minus f of 15. So g of 15 is going to be the cube root of 2 times 15 minus 3 minus f of 15, the absolute value of 10 minus 2 times 15. So this gives me the cube root of 30 minus 3 minus the absolute value of 10 minus 30. So this is going to give me the cube root of 27 minus the absolute value of negative 20, which gives me 3 minus 20. So that means that g minus f of 15 is equal to a negative 17. All right, so then h divided by g of negative 12. So h of negative 12 is going to be 1/2 times negative 12 plus 5 divided by the cube root of 2 times negative 12 minus 3. So that's going to give me 1/2 of negative 12 is negative 6 plus 5 over the cube root of negative 24 minus 3. It gives me negative 1 over the cube root of negative 27. So negative 1 over cube root of negative 27 is negative 3. So this becomes a positive 1/3, and that is h over g, h divided by g of negative 12. All right, so then g times h of negative 6. So g of negative 6 is the cube root of 2 times negative 6 minus 3 times h, which is going to be 1/2 times negative 6 plus 5. So this gives me the cube root of negative 12 minus 3 times negative 3 plus 5. So negative 3 plus 5 is 2. So I can bring that out to the front, and I get 2 times the cube root of a negative 15. So I can't take the cube root of 15. I can't even simplify that cube root, except that this is a negative 1 in here. I can take the cube root of negative 1, which is negative 1. So this actually becomes negative 2 times the cube root of 15. And that's equal to g times h of negative 6. And there you go.